So let's look at an example of how to employ the integrating factors, special integrating factors that we just learned in the last video. So look at this equation. This is the kind of equation where whenever we see an equation like this, we start thinking about exact. So you take the partial derivative of m. Remember this part is the m, so you take its partial derivative with respect to y. That would be 0 because this is just a function of x, which is a constant as far as the y is concerned. And then when you take the derivative of the n with respect to x, okay, the derivative of 2 is 0, and the derivative of this term with respect to x, so 3x cubed would be 9x squared, and then y to the negative 1 just stays because that's a constant in this case when you're doing with respect to x, and then you have a negative as well outside. So now we see that this is not an exact equation because my is not equal to nx. However, now we remember what we had for the special integration factors, that if it's neither separable nor linear nor exact, but we have to look at this quotient. Is this a continuous function of x only? So let's check this quotient, my minus nx over n. So if you do my minus nx over n, so my was 0, so you have to do minus nx, so it would become plus 9x squared y to the negative 1 divided by n, and remember n was this part. So now obviously this cannot be simplified any further, and we see that this is not a function of x only because it does have y running in it as well. So then that means that the integrating factor, we don't have this as the integrating factor because for this you should have had this as a function of x only. So then we look at the other one, the nx minus my over m, and try to see if that's a continuous function of y only. So nx minus my over m. Nx minus my over m is equal to nx is negative nx squared, negative 9x squared y to the negative 1. My is 0 divided by m. M is this part, so the 3x squared. But now we do see that the x squared and the x squared cancels out. This minus 0 can just be ignored. So the x squareds cancel out, and 3 times 3 cancels out with the 9 to give you a 3. And so this one simplifies into a negative 3y minus 1, which is a function of y only. And therefore, we have that I is equal to e power this, with this, the integral of this quotient is the integrating factor. So this quotient is negative 3y to the negative 1. The integral of that is negative 3 ln y, because this is y to the negative 1 is 1 over y. So integral is negative 3 ln y. And then you raise this to the power negative 3, so that there is nothing in between the e and the ln. So negative 3, we send it to the power of y. So the final thing is y to the negative q, y to the negative 3. So that's the integrating factor. And then the last thing we said in the previous video was that once you found the integrating factor, if you multiply the original equation by that, then you get an exact equation. So y to the negative 3 is the integrating factor. So multiplying this, all of this original equation by y to the negative 3 means multiplying each term by y to the negative 3. So the first term just becomes 3x squared y to the negative 3. You multiply by y to the negative 3 dx. And then you multiply the 2 with y to the negative 3, you get 2y negative 3. And then when you multiply this term with y to the negative 3, you have minus 3x cubed, and the y to the negative 1 times y to the negative 3 combined into a y to the negative 4, so minus 3x cubed y to the negative 4. dy is equal to 0. So now this one has to be exact if all our work is correct. So we can just check. So now this is our new m and this is our new n. So this the derivative, you have to, you have to take the derivative of this one with respect to y. So when I take the derivative of this with respect to y, let's write it. So my is equal to, so now this m is not the same m as the original one. Now we're calling this new one as m and this as n. So my is, so 3x squared is a constant, so that's just carried over. And then the derivative of y to the -3 will be -3y to the -4. So that will be equal to -9x to the 2y to the -4. And then when we try to find the nx, this is our new n. So when you find the nx, so the derivative of this one with respect to x is 0. And here we have a negative outside. And then the derivative of 3x cubed is 9x squared. 9x squared. And then y to the -4 is just a constant, so that just stays like it. So we do see that the two partial derivatives are equal. So therefore this new equation is exact. And this was just a check. If you just trust that you did everything correct, then it's not necessary. But usually it's a good idea, because sometimes if you make a mistake, then this mistake is caught at this step. You will not be seeing that the two derivatives are equal. And if that happens, it means you've made a mistake at some point early. So now you just solve the equation as we solve an exact equation. Solution is, you integrate this one with respect to x. So you have m dx. So you integrate this one. Integrate all of this. And there, for the second one, you integrate the terms which are free of x. So this term is not free of x, so this will be omitted, and only this one will be picked. So integral of 2y -3 dy is equal to c. And then the integral of this would be the integral of 3x squared would be 3x cubed over 3. So just x cubed. So x cubed y to the -3. So x cubed y to the -3. So this is x cubed y to the -3. And the integral of 2y to the -3 is 2y to the -2 over -2. So the 2's cancel out. So that's just y to the -2. Negative. Is equal to c. So that's our answer. X cubed y to the -3 minus y to the -2 is equal to c. X cubed y to the -3 y to the negative 3 minus y to the negative 2 is equal to c. Now, remember, we, at some point after finding the integrating factor, we multiplied both sides of this equation with that integrating factor, which was y to the negative 3. And usually when you do this, you can introduce a new solution, or you could remove an original solution. So you could either lose solutions of the original equation, or you could throw in extra solutions depending on what the equation was. So in this particular case, let's see, 1 over y to the negative y to the negative 3 is like 1 over y cube. So in this case, it wasn't as if there was a y is equal to 0 solution, which this one canceled. So this would, so a situation where this kind of a factor will make you lose some solutions was, let's say you had a y cube here and you had a y cube here. In the whole factor, you had a y, let's say you had a y cube sitting here as a factor and a y cube sitting here. And then when you multiply this equation by y to the negative 3, then that will completely cancel out that y cube. And now with the original y cube that would have been there, y is equal to 0 is also a solution. We can just see, because if you factor out the y cube from the whole thing, then you can see that y cube is equal to 0 means y is equal to 0 is a solution. And then multiplying by this kind of a factor would make you lose it. But in this case, that was not the situation. So 1 over y cube does not make you lose anything from the original. And no solutions are lost. Okay.